This is part 6 of my vertical engine build. For those of you that watched the last video, part 5, I mentioned in there that my designs aren't guaranteed to work. Well, after I finished recording the last video, I got to looking at the engine and I made a few little mistakes. Well, actually they're major mistakes. The engine does still turn, but I'm going to have to make a larger base and a larger cylinder support so I can get a little bit better clearance between the crank wheel and the uprights. The engine still does turn, and this video I'm going to go through finishing up the parts except for the replacement base, etc. Do the valve swivel, the eccentric and eccentric strap. So let's get to the machine shop and get to making parts. This is the eccentric and the eccentric sleeve. Got a little admission to make here. When I went to edit the video, all of the eccentric clips were gone. I had inadvertently deleted them, and I thought about what to do. I thought that this was a kind of an important piece, so I went down and rebuilt another one, or built another one. So we start first by drilling and reaming a 3/16 hole, a little over 1/2 inch deep and a piece of 1/2 inch stock. There's nothing too thrilling about that, but that's the starting point. So we get that drilled, and then get the reamer out. So that'll fit on the axle, on the main shaft. Then, after I got that reamed, there is a formula that I discovered a while back about how to make an eccentric using a 3-jaw chuck. I didn't have a 4-jaw chuck at the time, so I used this, and it's if I remember the formula, you put packing under one jaw of the 3-jaw, and the thickness of that packing is 1.5 times the offset. So I put that in, that packing in, it's 0.125. Worked out really nice since it's stock. Some of the others I've made, I've had to machine. Then I just go through with that packing in there and turn down the eccentric. I have a tendency to take a lot of light cuts when I'm working on this stuff. I could probably do a little quicker by making heavier cuts, but check it to see where I am. Back again. My goal is to turn this down so the diameter of the eccentric just meets the diameter of the part that's in the chuck. So turn that down, check it, and keep going on that. So then I'll make the strap that goes around that to fit with a nice slip fit on that eccentric. I'm not going to show this on the whoops video. I'm just going to show this part of it here. As a matter of fact, I'm not even going to complete this. Just turn it down, check the dimension, take it down just a little bit more, and the one that I'm going to be using on the machine Came out really nice. Then rechuck it in the center again, take the packing out, and part it off. After it's parted off, we take it over to the machine, or to the milling machine, drill and tap a number 6 set screw hole in the side of the hub, and that's it for the eccentric. I hope this explains things and not too disappointing from not being in the full procedure, but we got to cover up for our mistakes, I guess. So there it is. Now we move on to work on the valve and the valve swivel. The valve is what puts the pressure on one side or the other of the piston. Start by drilling a center in a piece of 1/4-inch stock. Then, with the center in place, move to cutting a couple of grooves, 1/32 of an inch deep. I tried to grind a grooving tool. It kind of worked. It gave me enough to get my 1/32 of an inch deep, but there were problems. Then I switched to a parting tool to do the 1/8 inch wide slot for the exhaust. Working on that for a bit, trying to smooth everything out. Then I had to take a couple of bites on that, since my grooving tool is 1/16 of an inch wide. And then there was a little bit in the center that I had to clean out. That went fairly well. So after getting that cut, then I decided that I was going to move on to parting off. I started parting off and said, wait a minute, there's got to be a hole drilled. So I drilled a hole from the end to just past the bottom groove. That's for the exhaust to pass out. That way the exhaust coming from the bottom side of the cylinder can exhaust through the top of the cylinder block. That hole is about a 1/16 of an inch. I didn't use a 1/16 of an inch drill bit. I used one out of the numbered. Then I go back to parting off. As parting went fairly well compared to my last experiences, although I do need to raise my parting tool a bit, as it is slightly below center. So when the tool passed through, I had to snap it off. Move to the mill. Now we have to cut a groove or a slot in the bottom of the valve. This is where it attaches to the valve swivel. I then, to avoid deflection, I used an 1/8 of an inch end mill, advanced it down 20,000th at a time until I got to a depth of 0.25 inches. So this took a while, since I was only going down 20,000th at a time. Cut a fairly nice slot. After cutting the slot, I rotate the collet block 90 degrees to drill the hole through the slot to accept the pivot pin. for the pin that hooks the valve and the valve swivel together. You know, typical here, spotting, then drilling a tap size hole for number 256. Then after that is done, drill one side of the valve with a clearance hole for number 256. And then I guess I got a little ahead of myself there. Now we're drilling the clearance hole. Just through one part. And then grab the tap, using the clearance hole as a guide, tap 256. Then we have to make the hole for the exhaust through the small slot, through the bottom slot, through the hole to allow for the exhaust to get out. Spot, and then just drill through. And that completes the valve. And there it is. Now we move to the valve swivel, centering it up in the collet chuck with the centering indicator. Just a little bit of tweaking here and there to get the spindle directly in the center of the valve swivel. From that, we then move on to the other part of the connection between the valve and the valve swivel, and that is milling off the sides to form a tang in the center that will fit in the 1/8 inch slot that was made in the valve. Again, working 20,000th at a time, so as not to get any deflection. I have the cutter set at 1/4 inch deep and just move it in 1/4 or 20,000th at a time. After that part, or one side, is done, then I switch it over to the other side, touch off, and do the same thing on the other side. So the tang is the appropriate width. Now, what I should have done here is after this was done, I should have turned it 90 degrees and drilled the through hole for the pivot pin. But I didn't do that. I turned it over, faced it off, and drilled the mounting hole for the valve rod. Drilled that down to as deep as I could, and then tapped it to number 256 for the valve rod. This will be the adjustment for the valve fitting, or the valve position. So when we do the valve rod, now I didn't have it tight enough in the collet, so I had to tighten that down a bit, but got it drilled through. And then I realized that I had to drill that hole. So I didn't show this, but after I got it tapped and realized, tapped it as deep as I could with the length tap that I have. I then realized I had to drill that hole, so I had to take the piece out of the collet, turn it over, and try and get the clocking right. I didn't include that in the video. Used a dial test indicator on the flat surface to set it up. I got it within a thousandth. Drilled the hole, and there we are. Well, this is the engine as it sits now. The eccentric rod, which I did off camera. The swivel for the valve and the valve. It does turn. There are a few binds in it, but as I said before, there's no lubrication as yet. But I don't know if I'll be able to see this on the video, but the crank wheel, I've got a pointer here. The crank wheel touches the upright and won't go as far back as the bearing where it was designed to go, and the main rod is sitting at an angle and rubs against the face of the crank wheel. So that's not good. So what I plan on doing is making a wider base. Maybe this is a piece of 2-inch stock. Maybe even going to a piece of 3-inch stock. Another thing that I was concerned about is stability. I think with a wider base, it'll be much more stable. But I'm going to end it with this video, and we'll do the run and probably make the new base and the new cylinder support. Spread these uprights out a little bit, and I think everything will work fine from that point on. So hit like if you like the video, subscribe, leave a comment. I've been getting a few comments and I really appreciate them. A couple people have asked if I'm going to make these drawings available, and I plan on it. Got to do some revising. After it runs, we'll see where it sits. That's all for now.